for refraction to occur. So it's more than likely it's reflection, which says it's kind of like a mirror, and therefore it can support many more angles than just the 0 to 15 as we saw for F2 region. So you still have to probably cover lots of angles. Maybe at the end, if you have any experience, if you've got a too high stack, you know, which one's better sometimes, most of the time, etc. I'd like to hear your comments on that. Okay, there's another mode that I think is very important with the digital modes. Normally, if the operating frequency is above the maximum usable frequency, the path shouldn't be open. And that's true for pure refraction. But in the real world, we have observations that indicate that a path may still be open if the operating frequency isn't too far above the MUF. But that comes at the expense of more loss. There seems to be some kind of scatter going on that still allows the QSO to be completed. Now, VOACAP, one of the most respected propagation prediction programs, has an above the MUF algorithm in it. And I extracted that, and what you can see is, for example, if the operating frequency is 3 megahertz higher than the MUF, you'll have about 28 more dB of loss. Now, you got to remember, from slide 8, there's minimal absorption at 50 megahertz, so there's lots of room for more loss due to the operating frequency being above the MUF. And this is what I believe the digital modes take advantage of, this above the MUF mode. Sporadic E, hopefully you've seen the plot there of probabilities. It's old data from 57 and 58, but it still seems to be pretty valid. You can see that in the summer months, there are positive probabilities from 7 a.m. to 1 a.m. For example, if you go to June, and you can see it, 0100 local, 1 a.m. local time, there's about a 10% probability that you'll have some sporadic E. And if you move up to 7 a.m. local time, it's about 10%, and then it increases, and it's bimodal. There's a peak in the late morning and also in the early evening. And there's a peak in the early evening in December too. So those are some of the times you should really be listening on 6 meters. Let me just stress the fact that there's a bimodal distribution here. That's very important. So let's work through something. Way back in 2006, N0JK worked JA7QVI, and I saw him, whoever was sharing the screen, I saw that call on there. He worked him at 2345 on June 4th. So let's assume that one hop via the sporadic E region is at most 2,000 kilometers, and that the ES clouds are independent. And that might be a stretch, but it's interesting to go through that little exercise. What that says is it probably took 5 hops to get from N0JK to JA7QVI. So what we can do is determine the probability for each hop from the local time and probabilities on the previous slide. And we end up with 5 probabilities, and we can multiply them together. And when we do, we get the plot on the top left there. That's the probability for JA to N0 in early June. And you can see the probability is highest around 0100 UTC. And John worked JA7QVI just before or late 2350 or 46, whatever it was. So I think that falls in line with all the West Coast to JA QSOs that we see. And some days are going to be better than the others, and that's why the distribution spreads out a little bit from looks like 2100 Zulu up to, you know, pretty low probability at 07, but it still might be there, and I kind of suspect that maybe power and antenna gain help a lot too. I also worked through that for W8 to EA8 in early June. It's a 3 hops. And interestingly, it comes out to be bimodal. At W9DXCC a number of years ago, when I showed that plot, I asked, has anybody ever worked Europe? At both times, around 1500 and also later at 0000 UTC. And yes, that does happen. So that's pretty interesting. And it allows you to kind of see what's the best time to work a certain area. I also worked that out for W2 to W7 and also from Kentucky to CT3, and pretty interesting. Now, going back to the JA7 to N0, the best, the time he worked them was around 0000 UTC, which is 7 p.m. at N0JK and 10 a.m. at JA7 QVI. And that falls very nicely in line with late morning and early evening in the summer for sporadic E. Now, if you reverse that, 7 p.m. at JA7, and that turns out to be 4 a.m. at N0, and that's not going to work because I remember I said that the probability was from about 7 a.m. to 1 a.m. So there wasn't much of a probability at 4 a.m. So the problem would be the N0JK end of the path. Over on the W8 to EA8 plot, 1500 UTC, when that QSO occurred, is noon in W8, it's 4 p.m. at EA8, so that worked out pretty good. And also at 0000 UTC, when the second peak is, that's 8 p.m. at W8 and 1 a.m. at EA8. So that was just right on the borderline of early evening and late, early morning and late evening. So yeah, it's pretty interesting to look at that. Took a while to generate all those, but and I think it's kind of works. So I also looked at some ES studies, and this is from Smith and others in 1958, and they looked at ionoson data for when the sporadic E critical frequency was greater than 5 megahertz. Now remember that if you multiply that by 5, that'll be the MUF for the sporadic E. So that's chart kind of shows probabilities for when the MUF is greater than 25 megahertz. And that's in the summer from 0600 to 1800 local time. And you can see they interpolated contour lines. And you can see there's some peaks in Japan, up in northern Canada, and also over northern Africa, southern Europe. Now remember, that was data from 1958, and I'm sure there was a lot of interpolation going on because of, there's no ionosons over water, which water is 3/4 of Earth. So there's some, I guess we could say guessing going on there. So let's move it up a couple years. Probably you remember Patrick Dyer, WA5IYX, and he listened to FM stations, 88 to 108, from 1980 to 1990, 11 years. And there's his data for the summer from 0600 to 1800 local time. And you can see he's in San Antonio, so that's data is really tied to San Antonio, and he saw in June FM stations up at 100 megahertz or so had sporadic E 60 to 80% of the time during the summer. That's quite a bit. He also monitored 2 meters, and that little graphic at the bottom there shows that 2 meter sporadic E is about 7/100ths of the sporadic E at 88 megahertz. And he also calculated it in time of minutes, about 3/100ths as much at 2 meters as at the FM band. He also did not see any significant correlation to the A index, which is an index of the Earth's magnetic field, and he didn't see any correlation to the 10.7 centimeter solar flux. And I think most people, I think nowadays, realize that sporadic heat is there regardless of where we are in the solar cycle. Here's the latest studies of the sporadic E. It's done by Wu. He's at JPL out in California in 2002. And what they did is looked at the variance of the GPS L1 and L2 frequency phase data. And that indicates that there's sporadic E going on. And this is the data for summer, the good old 0600 to 1800 local time, daytime. And what's interesting is it looks like Europe has more sporadic E than North America, at least back in 2002, compared to 1958. The intense sporadic E over JA back in 1958, it looks like it's moved west a bit to Southeast Asia. And the intense sporadic E in 58 over North Africa appears to have disappeared. And look at what may explain a lot of East Coast to Europe and also West Coast to JA. There's intense sporadic E now in the Atlantic Ocean, which is good for the US to Europe, mostly East Coast, and Pacific, the West Coast, to JA. So that's kind of interesting. Things are changing. So why are things changing? Well, it could be because the Earth's magnetic field is changing. Not only in strength, but also in inclination. In other words, the North Magnetic Pole is moving. And it could be in changes in meteor deposition patterns. And that's probably, sporadic E is dependent on meteor deposition. We're surrounded by meteor debris. And the process, wind shear and E cross B stuff kind of orders it into very thin, dense layers. We don't completely understand that yet. If we do, we could predict sporadic E. There could be changes in winds at E and lower F region altitudes too, so whatever. If you want to read more about it, check out N0JK's column in the August 2016 QST, his world above 50 megahertz. And there's a picture of at the top one is the magnetic field strength in 2008, and then 2008 minus 1908, so it shows the difference. And the bottom is the inclination. So again, if anybody wants any of these papers, I can sure send them to you if you send me an email at K9LA@ARRL.net. Yeah, I'm glad to share all that stuff. How about some other modes? Well, there's tropospheric ducting. That's a picture of the Hepburn Tropo Index. There's meteor scatter. I've never done meteor scatter. I've worked some Aurora when the K index is elevated, and of course you want to point north, kind of northish. And that picture, that was for Saturday, June 6th, Eastern North America. And it shows that there was some strong possibilities of some maybe tropo on the East Coast. So I don't know how accurate those forecasts are. Maybe somebody can comment on that. Here's an interesting one. It's called Theta Aurora, or another name is transpolar arc. And there's a picture of it. It's for the southern auroral oval. And you can see there's the auroral oval, the round, the ring. And there's a transpolar arc, and it's called Theta Aurora because it looks like the Greek letter theta. Now, I'm pretty sure this is what happened for KL7 working EU in June 2006. The transpolar arc was aligned from KL7 to EU in the northern oval. So that's probably what happened there. EME, I've never worked EME. And aurorally, that's something that Bob Hunsucker, who's a silent key, KL7CYS, when he worked at University of Alaska, he did a lot of work with aurorally, which is, it's a path that's tangential to the auroral oval. So it'd be something like that. My mouse going across, and he did a lot of that. And here's something interesting, short path summer solstice propagation, SSSP. JE1BMJ believes his summer high latitude QSOs are due to polar mesosphere summer echoes, PMSE. Now, what's a polar mesosphere summer echo? Well, there's a picture of the atmosphere on the left there. Of course, down at sea level, the temperature starts decreasing as you move up until you get to the tropopause. And then the temperature starts increasing in the stratosphere until it hits the stratopause. Then it starts going down, and the lowest temperature in the atmosphere is in the mesosphere. Why is that? Because in the summertime, the density expands, and that allows the lowest temperatures in the summer in the mesosphere. And we are setting records right now for how cold it is in the mesosphere. So this may have a lot to do with what JE1BMJ is hypothesizing. And there's a picture in the lower right of how he thinks his QSOs happen. There's the high latitude PMSE region. There might be just normal sporadic E on the two ends, and that couples into the PMSE region. There's some recent data that shows that those polar mesosphere summer echoes, the critical frequencies of the electrons are around 9 megahertz. So remember, for the sporadic E region, we multiply that by 5, so we get 45 megahertz. That's pretty close to 50 megahertz, so that's could be what's happening.
Yeah, Carl.
Yes.
The other day I worked TT8SN in Chad in Africa.
Okay.
On 6 meters, and he was about 9,400 kilometers. So
yeah.
that mechanism may.
Yeah, you probably had sporadic E. I don't know that TT8. How high in latitude did that path go?
Well, that's the thing, that the JA path is a high latitude path, but this was a low latitude path.
Well, what you got to your advantage for working TT8 is the equatorial ionosphere. It's the most robust part of the whole ionosphere. So it was probably a sporadic E, maybe coupled with maybe some transequatorial propagation or something.
Yeah,
who knows?
It's interesting. We've had every summer for the last 3 summers, we've had the Africa path open up. And I've never seen that path there. Maybe it's because there was nobody there, but you know.
Yeah, it could be.
It's pretty amazing.
Yeah, we got to remember there's a lot of things are changing, right?
Yeah.
On long time scales. We got the Earth's magnetic field is changing. What do you call it? Global warming. You know, things are changing. We can see changes very minute, but we can see them in the ionosphere. So
yeah, agreed. And the other thing too is that the guys in ZS in South Africa, they're complaining because they're not getting the sporadic E openings they used to get.
Yeah, like to Europe, Southern Europe, and all that.
Yeah, Europe and to South America.
Yeah. Things are
really interesting.
Yeah, things are changing. And there's probably a lot more changing than we realize. And we may be seeing them by being on the bands a lot over many years. So assessing real-time propagation. We have to remember that our propagation predictions all have one thing in common. They all use a monthly median model of the ionosphere. In other words, median implies 50% probability. So our predictions are statistical over a month's time frame. We don't have daily models of the ionosphere yet. So that brings up the question, well, how do we tell what's going on right now today? And I'm sure you guys have probably used all these. I use PacketCluster a lot, but then I go to DX Maps. That was just a couple of weeks ago. As you can see, the southern tier of states are roaring with ES, and of course, me up there under Lake Michigan, and well, maybe Dana might have had something there up in VE3 land, who knows. But there's WhisperNet, PSK Reporter. I was thinking about the RBN. I guess if there's a 6-meter SDR out there, you could probably get some, check RBN to see if you're spotted somewhere too, I suppose. I don't know how widespread 6 meters is though on those SDR receivers. There's also chat rooms. In fact, the Daily DX from W3UR mentioned, no, this was in the ARRL letter that just came out, that there's a chat room, a VHF chat room by N5TM. And there's the website for it. I guess I should mention that Paul has a copy of this PPT. So if he wants to send it out or post it, you can get all those URLs there from the presentation. Okay, remember we talked about if we knew the F2 region critical frequency, you multiply by 3 to get the MUF and all that. Well, here's some real-time F2 region data from ionosonts. That's the website, and what you'll end up is seeing a whole bunch of ionosonts throughout the world. So if you pick one of them, I picked the Eglin Air Force Base in Florida, and you can see that today's data is in blue, yesterday's data is in green, and then the past 5 days, they're just all jumbled together. So you can't really tell which are the past 5 days, but you can see today and yesterday very easily. And you can see that the F2 region critical frequency during the daytime is around 5 megahertz. So what that means is the F2 region MUF is probably around 15 megahertz. So that means 20 meters will be open. Of course, I don't think we'll ever see any 6 meter. Any FOF2 is high enough for 6 meter at solar minimum, but who knows? You can always listen. So that's kind of a way to look at that. And here's the real-time sporadic E data. And of course, it's going to be much spikier because sporadic E is sporadic. And again, just whatever the readings are. For example, this is the Point Arguello, which is Vandenberg Air Force Base. For example, it's 1700. Where'd my mouse go? There it is, 1700. It looks like the sporadic E critical frequency was just under 10 megahertz. Multiply that by 5. There's probably some sporadic E going on. You can see there's other sporadic E going on also. And you'll expect to see that. It's a slightly different URL. It's got FOES instead of FOF2, but if you want to look at that stuff, you can do that. Now here's something interesting I was thinking about. Back in my younger days, I was an airplane and instrument flight instructor. I even did some HF mobile in our Cessna 170. If you want to do some research, you can monitor localizer frequencies and also VOR stations. It's above 50 megahertz, so it'd be kind of interesting to see what happens. And the reason I mention this because recently a paper showed up in the American Geophysical Union's Space Weather Journal, where the authors monitored localizer frequencies, 110 megahertz or so, and they heard some of them 1,000 kilometers away. So if you can hear 100 megahertz 1,000 kilometers away, I'm sure there was probably some 6 meter stuff going on too. So if you want to do some research, this is something. And also the stations always have a 3-letter identifier in CW. Should be able to figure out which one you're hearing too, real easy. The digital modes. Okay. they offer a signal to noise ratio advantage. And from the WSJT documentation, I put together that chart, and it shows the sensitivity and the QSO times of the various modes. Now for CW, I measured how low I could hear a signal, how good I could copy a signal in a 250 hertz bandwidth, and it was a signal that was 2 dB below the noise. And I converted that to 2500 hertz because that's what all the digital modes are referenced to. And you can see progressing from JT65, which took a long time to make a QSO, but had good sensitivity. It could sense, 25 dB below the noise. And then FT8, things went faster, but lost some sensitivity. FT4 made the next step to get things faster. Then it lost sensitivity. And what I compared is, what kind of advantage do those modes have over my ability to copy CW? And it's still pretty significant. And I think a lot of the FT8 advantage and even the FT4 advantage, you can see how it could help with signals even lower in the noise or signals in the above the MUF mode when the MUF just isn't high enough, but you can give up some extra loss to still hear the station. Space weather banner. Okay. Here's what comes out if you look at QRZ.com or wherever else. Nice and colorful, but what's it all mean? Well, I've tried to summarize it. Up on the left banner, the little banner, the SFI is the solar flux. It was 71 on 7 June. SN sunspot number was 15, so we had some sunspots back on June 7th. The A index, it was pretty low. The A index goes from 0 to 400, so it was pretty quiet. K index goes from 0 to 9. It was pretty low, and it says that the geomagnetic field was pretty quiet. They didn't report any X-ray data, but that's the background X-ray that's going on. For example, it's solar minimum generally at a B or C level, pretty low. 304A, that's the ionizing radiation at 304 angstroms, which is 30.4 nanometers, which is about 60%, responsible for about 60% of the F2 region. And it's can vary from, probably 90 up to 300 or so. So this is just telling us we're at solar minimum because everything's down at the bottom. Proton flux, that's how many protons are in the solar wind. Normally it's pretty low unless there's a big solar flare. Electron flux, that's at geostationary altitudes. Aurora is how much energy is in the auroral zone. Of course, it's pretty low if the K and A indices are low. Aurora latitude tells you how low in latitude people can see aurora. BZ is the B component of the Z component of the interplanetary magnetic field. Generally, when it's around 0, things are kind of quiet. When it gets large, negative, that's when things are disturbed, and you'll see the A and K indices be up too. SW is a solar wind. Nominal average is about 400 kilometers per second. So this is kind of under the nominal. So it says things are pretty quiet. And here in the next one to the right gives some VHF conditions. And the next one is HF conditions. And there's a current solar image. It's at 30.4 nanometers. And there wasn't much sunspots, but that little white region is what was generating the sunspot number of 15. Now, what I summarized was for 6-meter F2 propagation in the fall and winter, you'll be looking for a solar flux index greater than about 150 up here, and the sunspot number greater than about 100. So we got a long way to go before we get there. And we generally desire the planetary K index to be less than 2, which translates to a planetary A index of less than 7. But you should also check the higher bands if the K index spikes up. You might be surprised. For sporadic E propagation, it gives a little summary here. For example, on June 7th, it says there was 50 megahertz ES occurring. So that's a good indication. Hey, maybe I better go check some other sources or get on the band. The Boulder MUF, where was that? That was over right here. They didn't report it. It didn't come from Boulder ionocide, I guess. But you can multiply it by 3 to get the MUF. And like I said, the 304 angstroms is 30.4 nanometers, the extreme ultraviolet, which is the big player in ionizing the F2 region. The June VHF contest. Okay, what's going to happen? Well, VE3EN had lots of neat data from 2004 to 2014. And he looked at the summer months, and he recorded when there were 5 or more contacts by multiple stations between basically the East Coast and Europe on 6 meters. So I went back and looked at all the previous June VHF contests, Saturday and Sunday, and what it in the green indicates there was ES reported. So if we look at Saturday, at least on the East Coast, there was about 55% probability on Saturday that you'd have ES to Europe. On Sunday, it was much higher. I'm not sure why, but it was. There was a 91% probability, except for 2004. All the other years had ES to Europe on 6 meters. Of course, this says nothing about W0, so whatever. What I think is still important, regardless of where you are in North America, is the probabilities by hour from slide 14, that ES sporadic E probability chart for 57 and 58. And this is this data taken off that chart, and it says, and it shows that, late morning is really the best time and early evening is the best time. That's when you should be on, and it should apply to W0. Last slide. Okay, what about Denver? Well, I looked at those studies that we went over, and I looked at their data from about 750 to 1,000 kilometer radius around Denver, because that's where the sporadic E would have to be for something to happen. And Smith's data says there's a 20 to 25 to 35% chance that the critical frequency of the sporadic E layer is above 5 megahertz. He's over here by me. Oh, he brought a mouse in. Yeah, bozo. Our cat brought a mouse in. Oh, well. Good job, Tiger. WA5IYX, of course, he was based in San Antonio. He said there was about it showed about a 60% chance of FM station ES, so that's pretty high. Unfortunately, the last paper with the GPS occultation stuff, doesn't look like Denver has much of a chance. It looks like it does have a little chance, but unfortunately that data doesn't give, how much, how good it'll be. And the other thing is tropo. I looked at the forecast from the Hepburn Index, and it looks like tropo is going to be possible for the Eastern North America. It doesn't look too good for Western, though. So, oh well. All I can say is get on the radio. Our forecasts are not 100% sure things, that's for sure. And especially check around late morning and early evening. So, Paul, that's all. Well, no, I got one more. That's right. References. And you can look at that on the PowerPoint slides there when Paul does something with them. So that's all I had, Paul.
Okay, great. That's awesome. I appreciate it. Hey, look at all the clapping going on.
Yeah.
Yeah, super. Thank you very much, Carl.
You're welcome.
That was the most detailed I've ever seen. I've looked for a lot of information on this, but I could never find it. I've uploaded the PDF of your presentation to
Okay.
files section on the Front Range 6 meter
Okay.
group web page there. So that should be
Yeah.
that should be all set up there. And
Okay.
just trying to see if I can turn off your screen here for a second.
You want me to stop sharing?
Yeah, why don't you just stop sharing for a second? That way, I think I can get back to normal. There we go. Now I can see everybody's faces.
Okay.
I've got a question when you get a moment.
Go
Sure.
right ahead. Yeah.
Regarding the ionosondes and the critical frequency, there's
Yes.
some reflection coming back from that ionosonde, and I am guessing that there's some minimum amount of reflection that's got to be received to say I've got something back, and below that is not good. Now, I was wondering with the newest modes, like FT8, are those measurements still valid? Because up to now, you would think about CW and sideband and saying, well, I can't have a QSO unless I get a minimum amount back. But now with FT8, you can do with a lot less. So I'm wondering if the maximum usable frequencies as we know them today are still valid, or what's the thoughts on that?
Yeah, that's a good question. Well, of course, the data is still valid. Yeah. And of course, going to the digital modes have caused some confusion. But remember, I talked about the above the MUF mode. So if you look at the critical frequency, multiply it by 3 for the F2 region, or about 5 for the sporadic E region, you'll get a number. But you can also remember that one graph about, well, it looks like if the operating frequency is above the MUF by a certain amount, you're going to incur a little bit more loss. Oops. Oh, okay. Cat's playing with the mouse down here. And so you can still apply it, and just remember that the real world will allow the operating frequency to be a little bit above the MUF, but at the expense of a little bit more loss.
I've done some FT8 presentations in Colorado, and I kind of expressed that. I was hoping I was right, as saying basically when you're doing FT8, you're basically extending the MUF.
You bet. Yeah, that's a big, yeah. And of course,
I think people just get on the air and try it.
Yeah, you know, JT65 would extend it even more. Which
enough power, anything's possible, right?
Yeah, yeah, yeah. Since that above the MUF mode appears to be some kind of scatter, power and antenna gain matters. Where normally you'd think that the MUF has nothing to do with power and gain; it's only the ionosphere. But since there's some scatter going on, probably, then power and gain matters.
And it also is a statistical thing.
Yes. Yeah.
Your chance of having a QSO, it's not absolute. Right.
Yeah, in fact, you can, we've done it, use VOACAP, just plug in the appropriate required signal to noise ratio for one of the digital modes, you know, JT65 or FT8 or FT4, depending on its sensitivity, and you can make some good statistical predictions.
Any other questions, guys? This is the time to get your deep, dark questions out to Carl here.
I enjoy your articles, Carl, except I don't really like them when you start out by saying, well, there are no sunspots again this week.
Oh, yeah, that's right.
You said there were 16 sunspots or 100 sunspots. Even if it's not true, it would make us feel better.
Oh, I'm sure it would. And yeah.
Just get those spots working up in the sun there. Do your magic.
Yeah, it'd be interesting. I was going to say something. I forgot what it was, though. Oh, well, whatever. I see there are 2 chats here. I wonder what those are. Carl, I worked at Zenith in the late 70s to early 80s. How about that? That's from Bill, WT0DX. And Dana in the E3 land says cycle 24, we had one F2 day here, OY9, and the beacon was 20 over S9, but only made 4 contacts in Europe. Oh, well, it's good to be in the wrong place, right? Oh, well.
Anything else, guys? I'm sure you must have some questions. Don't be shy.
Well, I'll ask obvious question, which is just before the meeting started, I had my display up and I worked the JA7QVI. So was that 5 ES hops?
I don't know. I worked it out for 5 ES hops. It might have involved some kind of chordal hop. It may have. I don't know how we'll ever tell.
Oh.
Really.
Just say it's a lot.
Yeah, in the references, WA3MEJ has a website that has a lot of VHF type papers. He has some of mine, and he has a number of K6 MIO's papers. Jim Kennedy worked in Alaska. How about Hawaii? K6 MIO stroke K86. And he's written lots of papers on 6-meter propagation mode. So it'd be interesting. It'd be good to read that because he gets into more than just multi-hop sporadic E and how other things could happen. And like I said, we'll probably never be able to tell what's really happening.
Can you gather any information from kind of the fading cycles? So I was watching the band and it was like 4 or 5 minutes, it would fade up and then it would fade down and then it would come up again and fade down again, back to that Japan path tonight.
I don't know. I'd have to think about that.
Okay.
The best thing we can do right now is get the pattern of the QSOs and then try to mate it to the pattern of what does sporadic E do, what does some of the other modes do, and see if the patterns line up. Yeah, there's still a lot we don't know up there, let me tell you. Yeah.
Hey, Carl, Jim K5ND had a comment there about the mesosphere, and you were saying how cold it is getting up there. How cold is it up there? I mean, like, is it compared to other years? Is this like a 100-year event that we're looking at right now, or is this something that happens every few years?
Well, I don't know if I'm not sure how far back we have data. You know, the mesosphere is at 80 some kilometers, which means I doubt if we have history like sunspots or anything. All spaceweather.com says is we're seeing record lows in the mesosphere. I don't know if it said how much lower, but right, it's probably around minus 95 degrees C up there.
They're saying it's causing some of the meteorites to ice up, or
yeah.
You know, you're getting some effect that's happening there. I didn't know whether it was affecting 6 meters at all.
So it's going to start hailing meteors. Is that what you're saying?
Yeah. Wow, that could hurt.
Well, and what I was thinking is if it's frosting those meteorites, how are they going to be burning up as they enter and give us meteor scatter? That was my little eye opener when I read that blurb.
Yep.
Carl, if I may, this is Jim WD0E. I've been on and off 6 meters at various times for about 50 years.
Oh, excellent.
Mostly from Colorado.
Okay.
I've never seen anything like the propagation we've had this spring ever.
Yeah.
And as an example, this afternoon I worked about 20 JAs, and at the same time I worked Kansas, and the 9Y and to Brazil.
Okay.
And I was hearing an HL, I just didn't have time to work him. I've never seen anything like that sort of widespread propagation. So is that an artifact of FT8, or is it the kinds of things, the kinds of changes you've been describing tonight, or is there more going on that we don't understand?
Well, there's probably more people have 6-meter rigs now. Yeah, the changes in the Earth's magnetic field. I've not seen anything on changes in winds. Again, the mesosphere is getting colder, which could mean the electron density is going up, which helps 6 meters. So I tell you what, when you figure it out, let me know. That's all I can say.
Hey, Carl, when I see these storms that are going across the U.S., like especially along across the southern U.S., I noticed a big jump in sporadic heat when these storms start coming up, or they start going up the East Coast, and all of a sudden I start seeing sporadic heats. What's is there a relationship now, or they establish it between high atmosphere storms and sporadic heat?
Yeah, that's an interesting subject. G3YLA has a blog, and it's in the references on that last slide. He's a meteorologist by profession, and he's also a 6-meter enthusiast. So it's interesting. I think he's doing a lot of study on, high pressure, low pressure systems and all that fronts. And how does that relate to sporadic E? I don't have the details, Paul, so I don't think I can, well, even if I knew the details, I'm not sure I'm well-versed enough to talk about them, really.
Yeah, some of those big thunderstorms and weather centers are getting up to around 40,000 feet. And
they can, the biggest ones I've seen, I can remember coming home from the West Coast one time, and we were over Oklahoma, Texas, and we were at probably about 37,000 feet. And those tops of the thunderheads were probably about 70,000. I mean, they were huge. So they, yeah, they can be pretty big. And I'm sure they cause stuff that we just don't know about yet.
Well, it's got to definitely rattle the mesosphere.
Oh, yeah. Well, no, that's, yeah. There's stuff in the lower atmosphere that couples up to the ionosphere too. And we're just beginning to learn and understand a lot about that.
Yeah, there's this whole thing about sprites.
Yes, yeah. Oh, yeah.
Just remarkable.
Yeah.
What's Sprite besides the drink?
Upward lightning. It's
Upward
actually,
lightning.
see the images, the lightning is flashing upward.
Oh, really?
Yeah, the space station, I think, had captured some good pictures, right?
Yeah, I think so.
Yeah, pretty interesting.
No, sounds like this.
We think we know a lot. There's a lot we don't know. A lot.
Well, that's what's so interesting about sporadic E, isn't it? I mean,
Yes. Yeah. Yeah. If somebody figures it out and can predict it accurately, we'll probably lose interest.
Well, this is the bottom of the solar cycle right now.
Yep.
And we're working Japan.
Yep. That's
I'm
not bad.
wondering what the hell's going to be like in 5 years when we're getting closer to the peak.
Yeah, well, you'll have sporadic E in the summer, and then probably F2 propagation to Japan in the fall and winter. So you'll have year round. Oh my gosh.
20 meters on 6 meters.
Yeah. Probably won't even have time to cut the grass or anything, right?
Exactly.
Yeah.
Okay, well, this is wonderful. Thanks very much, Carl.
You're welcome.
Appreciate your time today. I recorded this, and I'm going to be putting a link onto the Front Range 6-meter network there, so you guys can download it if you want.
Okay, great.
All right, thanks, Carl.
Okay.
7-3, guys.
Okay, bye-bye.
Great. Thanks, Carl.
Bye.
Thank you, Carl. Thanks very much.
Bye to everybody.
Bye, everybody.